Welcome to the All Access Podcast from the experts at Tevis. Each episode, we'll talk about technology topics, trends, or solutions that manufacturers need to know in today's rapidly evolving times. Sit back, enjoy the discussion, and let us know what you think.
Well, hello, my manufacturing friends. Welcome to the All Access Podcast. I am your host, Michael Thiessen. Every 2 years, we're running into this cycle here in the Midwest where we become actually important. A lot of people are flocking towards the Chicago area, and you probably already understand where I'm going with this, that IMTS is coming up. So we're trying to find out what's all going on. And of course, I don't have all the answers. So we're trying to find this guru, that guy that knows everything. And we stumbled upon a gentleman from AMT, the Association for Manufacturing and Technology. And he has all the nitpicks and the ideas and the things that are going on, the things that are hot and the things that are not. And he actually agreed to be on the podcast. Without further ado, I'm going to introduce here Stephen Lamarca. He is the Senior Technology Analyst for AMT. And believe it or not, AMT is the host of the IMTS show, the upcoming IMTS show. He loves to deal with 5-axis CNC mills, also with cobots and all those kind of cool things. Without further ado, Steve, hey, thanks for being on the podcast, my friend.
Michael, thank you for having me. What an illustrious introduction that I absolutely don't deserve. I'm not that guy, but I can help you find him, okay, or her, whoever it may be. But I don't have all the answers. I know enough, and I can help you. I can help people find the answers. But thank you. Let me just say that.
Well, you know what? It's not every single day that we talk to people from the AMT, and it must be an exciting time for you for being involved in the upcoming IMTS show, because it is such an incredible show. And you guys must be super busy in getting everything prepared.
Yeah, it's definitely go time.
I mean, it's such a huge show. I mean, everybody from any part of the world usually flock to Chicago, and they come in, they take over the city, essentially. If that's people from Japan or people from China, Italy, Mexico, I mean, you name it, you find every country represented, and they come together in that one area, McCormick Center, and making it their home for that week. And it used to be, I mean, I've gone now for the last 20 years or 20 plus years to the IMTS. It used to be a week and a half, and it was an ordeal if you had to work the show. But it is an amazing event.
It really is. And, I know I have some internal bias, but I get to go to a lot of really cool shows as a senior technology analyst. But for example, last year, I had a 2-week stint of traveling. I spent a week late October going to SEMA, which is not typically something that a manufacturing industry person would go to. But I went there in the hunt for what manufacturing technology is getting people really excited. And I got to meet. If I went for one thing, I really went because I wanted to meet a really cool manufacturing company that doesn't get enough credit in the manufacturing industry, called Send Cut Send. I think they're a really cool company. I call them Xometry for auto enthusiasts, because I'm a huge consumer of internet content, especially YouTube, and I also really like cars and motorcycles, and a lot of people who also share that passion for those hobbies, when they like to tinker and modify what they have, sometimes, it's not, you can't just buy everything. Sometimes you do have to get your hands dirty and do some fabrication. Well, good parts aren't manufactured, aren't manufactured with just simple tools. Sometimes you need some advanced manufacturing technology. And SendCutSend is like one of those companies that I'm really pleased I got to meet, because they will let you don't have to have any experience. If you can draw something with crayon on a piece of cardboard, and as long as those dimensions are right, you can mail it to them, and they will, and what you want, and with the appropriate check, of course, they will send you back a fabricated piece of whatever material you're asking for, but your desired part, back to you. It's a really cool company, and that's what I got to meet at SEMA. And then immediately after SEMA, I spent a week in Vegas at SEMA, which was a blast. I've always wanted to go to SEMA,
especially over Halloween.
Yeah. And then immediately after that, I went to my first Formnext in Frankfurt, Germany, which was amazing because when I got there, and there's a few AMT people that went to Formnext, but when I landed in Frankfurt, I had like the show started. Formnext starts on a Tuesday, and I didn't really have anything to do that Monday that I landed, and I landed at like noon. First thing I did, rented a car in Germany on my own dime, and I drove it out to the Nürburgring. And this was my first time in Europe. This was really like my second time outside of the United States. Honestly, it's pretty sad. But I'm just really proud of myself and pat myself on the back for having the guts to be in a different country where there's a lot of paperwork and not a lot of common language. And actually, they're really good about speaking English. But and I just went on a road trip as soon as I got there to see the Nürburgring, and it was awesome.
My job feels boring towards you. Are you hiring? Man, the amount of technology that you can see or that you're seeing before anybody else must just be mind-blowing. I mean, when I go to the IMTS and I see the technology progress over these last 20 years, it is just mind-blowing the amount of technology that comes up every single year. And you see it firsthand because you're going to a lot of these shows and you see some new technology that comes up. What stands out? What is something that you think some of the listeners, if they're going to IMTS or maybe they're still thinking about going, what would you say, hey, pay attention to this?
I will always say, and this goes back to a internal to AMT project that I was put on in 2020. We had a priorities project, and the goal was to quantify the number of transformational technologies and identify which ones they are, and then become SMEs about. And we highlighted 6 transformative technologies, technologies that were either in or emerging in the industry that would not necessarily disrupt, but certainly transform the future of the industry from where we are now to where we're going. And that was 4 years ago now, and it's not as relevant as it was at the time. But the one technology that absolutely stood out to me, and it stood out to me at IMTS in 2018, and I like to I don't label it as an emerging technology because it's obviously not emerged. It has emerged.
It's already here. I think I know where you're going with this.
But it's constantly evolving and it's getting better. And I like to label it as a foundational technology because it will always be holding up whatever the next buzzword is, whatever the next buzzy technology is. It will be the one supporting it, and it's automation, hands down. I remember one of the coolest things that I saw. One of my key takeaways from IMTS 2018. I know this is a long time ago, but there were just robot arms everywhere. And in some cases, in a lot of cases actually, not even plugged in, and just like standing on the floor of the show holding bags for people to take so they can put all of their show swag in there. And I'm like, dude, that is a $70,000 coat hanger. And so my prediction from having come away from 2018 back then was automation is going to be in a surplus soon. It's going to get less expensive because it's everywhere, and it's still everywhere to this day, and it has gotten less expensive. There was a company, a Chinese company that I got into contact with because, I don't know if you mentioned it, but one of my duties, one of my roles at AMT is to manage our technology test bed, which I can go into that later. But we were looking at the time. Our technology test bed was only 2 years old, and we only had one piece of technology on it. And it was a Pocket NC, a desktop 5-axis horizontal CNC machine. And my boss, Ben, was like, hey, let's get a robot. Find a robot. But because we're an organization, we're an association, we're not like, a Beltway bandit, even though we have a building next to them. And we're not making parts, so our budget for the test bed is like very, very slim. And I did a little market study and looking at automation and looking at robots, and it was torn. I was looking at our options, what we had to buy, and then looking at the budget. It was like, well, the most high-end, the most advanced educational robot is $2,000, and it's the size of a shoebox, and it's only has 3 joints, and it doesn't have modular end-of-arm tooling, which at the time may have been called end effectors, but now it's that end-of-arm tooling, and I have to harp on that a lot. And the least expensive industrial and or collaborative robot in the manufacturing field was like, I think $30,000. And so there's a 20 I'm doing my math. There's a huge gap, from $2,000 to $30,000. There's a huge gap in no man's land of where there should be robots. There should be prosumer. It's not quite industrial grade, but it's more than the educational grade that you'd see in a public high school. There was this gap filled, and I worked with this Chinese company, U Factory. And they had in 2019 at CES, they debuted a 6-joint collaborative robot called the X-Arm. And at the time, now they only have a 6-joint, but at the time they were going to roll out a 5-joint, a 6-joint, and a 7-joint, depending on what your budget was. And I was talking with them, and it was really fun having these meetings. Like I'd be on like a Teams meeting or a Zoom meeting, and because it's a Chinese company, there was like 7 of them. There's 7 U Factory workers on this call, and they were all taking notes to what I'm saying. I'm like, guys, stop! I'm not that guy. Really, I'm not. And they were like, well, if you were to price this robot, that was the main question that they wanted to talk to me about. Was, if you were to price this robot, where would you price it? And I was like, well, the cheapest industrial grade robot, the cheapest collaborative robot or industrial robot that you'll see at IMTS is $30,000. And the most expensive accessible robot to a civilian is $2,000. And it's kind of junky. You're not going to do much with it. It's really for training and teaching purposes. So, and then I thought about the test bed budget, and I was like, if you guys release this guy at like 10K, we're in. And you'd have I didn't say that. I said, if you release it around like 10K, you're going to have so many buyers, meaning you're only going to have like one buyer, me. But please make it affordable. Automation will always be foundational. To come back to your initial question, automation will always be foundational, and you want to pay attention in where it's going. IMTS 2022 was awesome because we saw, I forget the name of the company. I want to say it starts with a V, and it was only like 4 letters, but it was in the North building. And their booth was so cool because it was empty. There was nothing in this booth, and there was like a cage around the booth. Not like a cage, but there were like, 4 pillars in each of one pillar in each corner. And there was like, the trellis going up, and on the back wall, there was a big television. And in front of that television, like mounted either to the wall, that the same wall that the TV was mounted, or mounted to like the ceiling of the booth, was a pretty large industrial robot, not a collaborative robot, an industrial robot. So the type of robot that typically exhibitors need to reach out to us and be like, hey, we got to know all the safety standards that we need to follow and what rules we need to follow to be able to show off this robot. Typically, a robot like that, there would have to be in a pretty substantial enclosure or some sort of serious safety fencing, safeguards around it, because it is an industrial robot. It's a collaborative robot. It's not meant to play nice with soft humans. And it was just the one robot. And it wasn't even their branded robot. It was a pretty big name brand, like Kleenex of robot brand, if you get where I'm going. And it was swinging around really fast. And the TV behind the robot was showing what the robot was looking at. And this TV also had little hot spots of all of the people walking by. And as you approached this robot, they were like, yeah, come on into our booth. As you approached this robot, the robot slowly reduced speed until you got within a certain range, came to a complete stop. And now that's pretty commonplace. It's not really done as smoothly as this company did it in 2022. But what was really impressive to me, because one of my favorite things to do at manufacturing trade shows, especially ones that are showing off collaborative robots, is getting kicked out of automation booths or robotics booths by going in there and pushing, testing the collision detection of all their cobots, making them come to a complete stop, making all of the failure lights pop up. And I like to see how quickly the people working that booth can get those robots up and running again. And, the first time I did that was in 2018. I got pretty quickly shooed away from some of the booths. But I'd like to think that I helped influence these companies at getting better at restarting their robots. And it's a lot easier now. You see a lot of the companies be, okay, reset, maybe have to home the robot and then cycle start the robot again. But what was really cool about this one company in 2022 is as you stepped away, it gave itself permission to start going again.
Oh, wow.
And this was not a collaborative robot. This is an industrial robot doing collaborative things.
Wow. I think you and I are exactly on the same wavelength when it comes to the upcoming technologies that people need to watch out for. The interesting thing is, you look at automation in terms of, okay, robots, cobots, that kind of stuff, where we or I, from the software portion of it, we look at automation of, okay, I don't have as many workers anymore or programmers. I don't have the experienced guys anymore. I need to somehow replace that loss with technology. And if that means that I need to have either a robot loading my pallets onto the machines or the milling machines, or I need to have automation built into the system, either with AI or additional functionality that a software comes along that can enhance the entire 5-axis operation or anything like that. So you and I are very, very in tune with what the new functionality needs to be. And the thing that you mentioned earlier too, 2018, you said that you already saw robots at that time. Remember too, that was before COVID. I know we all forget about all of this stuff, but then during COVID, this really became into focus because companies were shut down. Machines were not running. People were looking at, oh, crap, how can I get these machines up and running? And all of a sudden, automation shot to the forefront. And this became then, after COVID, a lot of companies then started looking into it and saying, listen, I need to figure out how to do automate. And believe me, when we first came out with automating and templating in our software, the mold makers gave us a lot of grief. Oh, we can't do that. We can't automate. We're doing different jobs every single different day. You can't do it. All of a sudden, then after this, they came up and say, we need to do something. And that's exactly the point.
Yeah, you set up a perfect transition for me, but before I execute on that, I do want to say that to think positively and be more on the positive headspace. A couple awesome things that COVID brought us was it showed us that even amidst a supply chain kerfuffle that would unfold and be pretty disruptive, the manufacturing industry, or the industry all over the world, joined together and retooled production lines on the fly, on the whim, to help overcome a potentially very deadly pandemic. And it actually was very deadly. I'm not going to say potentially, it was. I thought I was writing the weekly tech report at the time, and people at work were giving me a lot of kudos because I was putting in all of this like positive stuff, but it's like, it wasn't me. That was just my news feed was filling it was writing itself, like hearing that Lamborghini had stopped their production lines making cars and shifted their production lines, which they actually, kudos to Lamborghini, they use a good amount of additive manufacturing, which is really fun, obviously. But they retooled a lot of their production lines to make PPE, ventilators, swabs. But one of the coolest things that Lamborghini did was because during their shift to PPE, they were very strict on who got their PPE. They wanted to make sure that their PPE only got to first responders, and they actually became like a luxury designer brand of face masks. And you could see some of these Lamborghini branded face masks, and they were very animate about making sure they only got to nurses and doctors and EMS responders. It was really cool. But
could you imagine 4 years after you look at this and you say, hey, look at this. I got a Lamborghini sitting here.
I got a Lamborghini face mask. And people we're still in like a mindset, like we're trying to forget 2020, but like maybe someday they'll have really some awesome value on eBay. But going forward, I did a lot of talking about the past, and you probably want to hear about, well, what's next? And the truth is, I can't tell you what's next, but I can tell you where we're going. And you made me want to touch on automation, AI, and digital twin are what's next. And those are bolstered by automation. But specifically, I think, we're still, because of the pandemic, we're still in like a mindset of, well, wait a minute, remote work is working. It's sure, it's had its hiccups, and some people are still against it, and some people are totally for it. And the truth is, you need a balance. Like, some people do need to be on the job site, but some people can work remote. But automation, AI, and digital twin technologies, especially in manufacturing, will enable machine tool operators and machinists and technicians to work remote.
I cannot agree
at least
with
hybrid.
You more. I cannot. Digital twin has been a word at least from our side, it has been utilized for many, many, many years. And digital twin AI, I mean, when AI came out, I mean, who has not heard of all this AI stuff that you type in? It creates all your articles and all that kind of stuff. But do you think that, I mean, yeah, I was going to go towards give me your 3 to 5 year prediction, but I'm going to stop there. But do you think we're going to go towards a Terminator kind of look, where all of a sudden robots become more? And I know I'm going sci-fi on you, but do you think we're getting there, where all of a sudden robots become now more and more every single day life kind of deal?
Robots will become more and more everyday life will be a more everyday life ordeal. I am positive it won't go the way of Terminator. There are a lot of people who are concerned about that, and it's okay to be concerned about that, because that means there is a demand for people to ensure and program and write and develop safety guidelines to make sure it doesn't go that way. But at the end of the day, and if you quote me on anything that I say here, I want you to quote me with this. It doesn't matter. And I'm going to say it because the current buzzwords, the current technologies to focus on of the time are AI, automation, and digital twin. But this holds for the future too. It doesn't matter what those are, what they are going to be in the next 10 years. These technologies are just tools. Nobody lost their job to a wrench. Many people have lost their jobs to some other people who can wrench better than them. But these technologies are just tools. Learn how to use the tools.
So, I mean, what we have done here at Tebis, because we went to a new version 4 years ago, and you might understand this because you're in the 5-axis world, that we went away from just utilizing or making toolpaths, just utilizing a head or maybe just a tool, what was standard for the 1980s and upwards, just utilize a very primitive type of way of showing your machine head, to now telling clients, hey, listen, leave the 1980s behind. You need to have simulation equipment, that digital twin that you have sitting out there, so that you can really figure out what's going on without running it and then afterwards going, oh, crap, we crashed the machine. You want to know all of these things beforehand. And there's companies that are resisting this because they're trying to hold on, because they're saying, well, it's working for me. I don't need to switch. I don't need to have these simulation tools. I don't need to have these machines. And I think they need to grasp the new technology that is there. What would you say to some of these companies that are kind of resisting and kind of holding back on? And do you feel that maybe at one point in time they will have to go down that way because there's no other way?
I think so. It's crazy to me that people wouldn't simulate. Like, I mean, I don't care how much you're paying your CAM engineer. And I realize some job shops, in fact, probably a lot of job shops, get a file, like their machinists, their operators, their machine tool technicians, get a file from their CAM engineer and upload it into the machine, make sure the stock is in place, make sure all the tools are in place and have good life left on them, and hit run. And maybe for the first part that comes off, they'll be hovering over the e-stop. But that's wild. That's a lot of trust. And that person, that CAM engineer, is trusted with a lot. I mean, they're probably making a solid amount of money, and they probably have been doing it for a while. I understand why they wouldn't simulate. But from my standpoint, when I started at AMT and was told to build the test bed that we have now, and when the test bed was just the 5-axis Pocket NC, when I was learning how to use that and becoming an amateur machinist, I learned pretty quickly that as soon as you have a program, doesn't matter where you get it, doesn't matter if you made it yourself and you validated every single line of code, the first step should always be, and this is probably what the CAM engineers do before they hand it off to the operator. I'd like to think that's what they do, is you simulate it. You absolutely run it in a simulation. If the simulation looks okay, if lines don't cross where they're not supposed to cross, then it's like, okay. But even still, I wouldn't hand off a file. And this is just me. This is just an amateur, somebody who barely knows what they're doing. The next step, because I was the CAM engineer and the machinist for our test bed, and had no deadlines to meet or customers to fulfill, after the simulation looked good, assuming I knew what a good simulation looked like, and I used a free simulator because I was learning a lot from this young guy, this student. his name was Xander Luciano, and he was an intern at Autodesk at the time. He had actually wrote a free website that's still up today called ncviewer.com. And I was just uploading my programs to that. That was written by a student, and he made it free. But anyway, after that, I thought looked all right. Then I would upload it to the Pocket NC. No tooling, not even a tool holder, no work holding. Absolutely no stock material, just a bare machine, no vice even, and just run the program. I'd do an air cut. And if nothing, and even during that air cut, like where minimal, damage, minimal, casualties can happen, I'm hovering the e-stop button. Well, it was the earlier Pocket NC. It didn't have an e-stop. It had a pause button, but I was hovering over that pause button. And if that worked all right, then I would throw in the tooling and air cut with tool and work holding in place. If there was no collisions with that, then I'd throw in a piece of wax and I'd cut that. If the wax part looked all right and there were no hiccups and the sound was all right, then okay, we're good to cut some plastic. And that is absolutely not how any manufacturing facility makes money making parts like that. But, somebody who was just learning and trying to figure it out, that's how I would do it. And it's so I now know and understand why there was so much, I don't want to say hostility, but hesitance to like when I published the article a couple of years ago, Cam GPT, when I was starting to fiddle with Chat GPT, and I was like, oh my God, this is amazing. And Cam is like my biggest nemesis. Cam and I don't get along. I struggle with it a lot. And we can talk about that later. I'd actually love to, and hopefully not get in trouble with Tebis. When I was like, oh, can I finally get an AI, something to program a G-code file for me? And I posted something on LinkedIn because I posted my screenshot of what ChatGPT printed out for me. I typed in, I'm using a Pocket NC. I want to make a shot glass out of 1-inch Delrin bar stock, and I have a 1/4 inch 3 flute corner radius end mill. Give me code. And it comes back because it's a chat, it's conversational. It's like, we need a little bit more detail. And it asked me a few more questions. I forget what they were. And I gave it all the detail. Oh, this is the size of my stock. This is where the stock is located in the machine. And this is the offset. What's the G code look like now? And they're like, all right, got enough information. Try this first, but make sure you simulate it first. And it said that. It like the result even told me, don't just like run this in there. Simulate it first. And now it didn't end up working, but it wasn't a crash either. And I was just really excited by that but where I was going with this, I'm sorry. I posted this on LinkedIn, my adventures of this on LinkedIn before I turned it into an article. And I got so many hesitant, pessimistic comments saying, you're nuts. Nobody ever would upload a CAM program onto or a program onto a machine tool that was written by an AI. Like that's just begging for a machine tool crash. And I'm like, why would you think that I would do that? Have you not heard of simulation? Have you never run an air cut before? But then I realized, production machinists, production CAM engineers, the CAM engineers might, but production machinists, people who are filling orders and have to have it shipped by the end of the day, they don't have time for that. They put their trust. That's why the CAM engineer gets so much money. So I hadn't put that together, but I'm like, well, AI needs some experience too before it can be trusted. And we're getting there. We're building it.
I really think those 3 words that you said is the roadmap for the next 3 to 5 years. AI, digital twins, and automation. Those are the 3 big building blocks that we're going to be working on, because AI can be utilized for so many different things, not just for writing code, what you just mentioned, but what about creating a feedback loop? You're running something on the machine, maybe the cutter starts to vibrate. feed that back into the system again, trying to figure out, okay, why is it vibrating? Oh, maybe the tool is too long. Okay, reduce the tool and do this all with the simulation first until you take it back outside again to the machine and rerun it. There's a lot of things that are going on internally to Tebis. We're fiddling around a lot with the AI tools. I know some of our clients, they're doing the same thing. A lot of the PhDs, minds that are working on this, it's fabulous to see that those kind of things are being used. The simulation, the templating. I mean, we're seeing a lot of the baby boomers are retiring now. They have a lot of experience, a lot of know-how, and there's the younger generation that comes in that doesn't have that experience. So how can we transfer this experience that the old guys are taking back with them into retirement? How can we get that back to these young guys?
Oh, you're just teeing things up for me. Okay, so a lot of like the young people, such as myself and younger, I'm not young anymore, but I can still see it. Millennial and younger PC gamers find the company NVIDIA synonymous in gaming, find that company name synonymous with a PC gaming technology buzzword, ray tracing. And when we talk about AI and digital twin, and link that back to simulation and trusting simulation and going back to maybe not the current state, but the state of CAD CAM from a couple years ago, CAD and CAM programs were really good. They focused on one of the most important things with manufacturing, which is part dimensions. The dimensions need to be perfect. We're always going to be in the hunt for the almighty micron, but CAD CAM programs had the problem of only focusing on dimensions. And while that's okay for CAD, and it, sometimes other companies would do some things to make the parts look more realistic, and so dimensions and visuals are very important. The next step with CAM, what CAM needs and what our simulation needs to make the best parts possible and to minimize any risk of catastrophes inside the machine tool, inside the production process, is we need more of the laws of physics than just dimensions and visuals. We need all of Newtonian mechanics in the AI simulation model, or in the simulation models, and that's going to be only possible with a grasp of digital twin and an AI to enable it. And the reason why I mentioned gaming and ray tracing goes as far back as, it's not actually an NVIDIA pioneered technology. Ray tracing, don't quote me on this, goes as far back as when I was in late elementary school, early middle school, and I bought my PlayStation 2. And
are you dating yourself now?
I was gifted Gran Turismo 3. Gran Turismo, a game that their tagline is the real driving simulator. It was like one of the first good driving sims that was still fun. That game, Gran Turismo 3, was developed and published by a developer that was owned and still owned by Sony. But that developer, Polyphony Digital, pioneered ray tracing. It was software based. It was in the game, and it was very demanding on the hardware. But ray tracing is in gaming and in special effects. What is rendered is usually what's on screen. You want to save resources by not rendering stuff that's off screen and rendering it as it comes on screen. But ray tracing is, I'm going to do a really bad job at explaining this, but ray tracing is following the physical properties of rays of light. So you get accurate visuals accurate lighting in a 3D synthetic, a fake virtual environment as possible, because you are following the laws of physics of light, and you are pre-rendering the dimensions of the environment of a digital twin, the environment around, whether it's a movie or a game. So the light is bending and bouncing, and you're getting realistic reflections in your game or movie via ray tracing and following the laws of physics. And that's just light. And we need ray tracing in the manufacturing industry and for digital twin technology everywhere else, not just light. We need to know how certain cutters with certain coatings, and is it high-speed steel or is it carbide, with what kind of coating? How does that interact with what kind of material? Are you cutting brass? What kind of brass? Is it conventional real brass, like traditional brass, or is it machining brass with a little bit of lead in it so it doesn't gum up when the cutter's spinning on it? There's a lot to, and it starts with that. And one of the pioneers for hardware-based ray tracing, which is much more stable and much more accurate than what Sony created back for the PlayStation 2 or back for Gran Turismo 3. NVIDIA has hardware-based ray tracing, and NVIDIA also pioneers a lot of the GPUs, graphics processing units, for AI development as well. One of the file formats for which effectively is going to be the file folder format for all digital twin files and documents going forward, is something called USD, Universal Scene Description. And that was invented by Pixar, the biggest 3D animation studio in Hollywood and probably the world, if not the universe. Not trying to hype up Pixar, but they created USD back in 2010. In 2016, they released Open Universal Scene Description, which is made it open source, allowed other people the permission to use that. And they weren't doing a charity. USD became such an ordeal that Pixar realized, hey, we need to open this up to the rest of the industry, because Pixar, the company, the movie making studio, animation studio, was starting to do more work and get more involved and put more of their time into developing the standard than they were making movies. And movies is how they make money. So they open sourced it to make it better. Obviously, the manufacturing industry and gaming industry can utilize USD a heck of a lot by creating digital twins. And not only can games look better by opening this new world of known Newtonian mechanics or laws of physics, but the manufacturing industry can greatly benefit from this digital twin technology.
You're 100% correct of utilizing that type of technology, making it more realistic when it comes to the simulation or when you start programming. Let me quickly switch to this because we're coming close to the end here. I promised to the listeners that I have the guy here, which you said at the beginning that you're not the guy, but you're the guy. You're the guy.
I just failed to answer your question. So how we're going to get the next generation of workers involved? Well, they're really involved in games. And if you tell them how games are involved with digital twins and why digital twins are necessary for manufacturing and all the amazing fun things around us, like the reason why I love working at AMT and love working in this industry is because all of my hobbies, expensive hobbies, all come from manufacturing. Cars, motorcycles, wristwatches, the best stuff comes from the best manufacturing technology. So it behooves me to work in this industry. And I think the other young people will see that too.
And I think having people, maybe they have registered, maybe not. I think in 2022, we had something like 86,000 people visiting the IMTS show. I predict maybe this year it's going to be even more because people are coming more out. They want to see what the new technology is. And I think over here in the US, we really are craving technology. We want to have the best of the best. And there's more and more manufacturers coming over here. What do you think we could expect to see at IMTS? What do you think is going to be outstanding, or what you already got a glimpse on? And I know you're probably going to say Tebas is going to be outstanding. So I'm just going to put that in there.
Of course. I want to see what's next in CAM technology through Tebas and what Tebas has to offer. And of course, there are excellent competitions such as Autodesk and Open Minds, Hypermill, and Mastercam. Not to pick. I try my best not to pick favorites. But what we can expect to see is IMTS is just. I know I sound biased, but it's just this. I've been to so many amazing trade shows, and I truly believe. I don't think it's just bias, and I don't think it's just because they give me a paycheck. I truly believe that the IMTS is the greatest trade show that I've ever been to, and I think that's because. It's not just about supply chain. It's not just about automation. It's not just about additive manufacturing or rapid prototyping. Like, it's about manufacturing and it's about the supply chain, but it's also about what's the next technology, what's the next software. Like we're going to have exhibitors like NVIDIA, a GPU manufacturer, designer, and Amazon Web Services, and Microsoft was like, what are they doing here? People are going to be asking that, and you're going to find out. But IMTS is great like that because it's not just about individual things. It's about all of them and how things come together. I do believe that if IMTS, if Leonardo da Vinci was around when IMTS was having shows, he'd be attending to see what's the next paintbrush that I need to be using.
Oh, yeah. But the cool thing is, it's not just the mold makers that come in there or the die makers. There's a lot of aerospace companies that are walking around or exhibiting even. There's a lot of job shop guys that come on there that make small little widgets and gadgets. And it brings everybody together that is in manufacturing, that utilizes technology and want to find the latest and greatest. And it's so much fun for me when I'm usually there and have a conversation with individuals to what brings you here. And I learned so much from these guys that walk by of what they're looking for in order to just open my mind and open my ears and see, maybe I should be looking at this too. So it's exciting. Are you going to be at IMTS?
Absolutely.
Good.
Yeah.
Good. So before I come to the end, you talked about quickly this test bed. You alluded to it. What is it before we go? And tell the listeners, what is this AMT test bed that you've already mentioned several times?
AMT Test Bed is a development environment for experimental. To run experiments as you would in a development environment for manufacturing technology. And the reason why we have a test bed is the struggles that the industry goes through are the same struggles that AMT goes through. We've got a lot of young staff here that have not been in the manufacturing industry. So we want them to be able to hit the ground running and visually tell the difference between a 3D printer and a 5-axis CNC mill, know the difference there. When they look at the mill and they see this tool, this drill bit looking tool, we want them to be able to tell the difference between, no, that's not a drill bit, that's an end mill. And it's so it serves, that was a long-winded way of saying it. One of the purposes, it serves as a means of education, both for internal staffers that might not have manufacturing experience here at AMT, because I absolutely did not before AMT. I didn't even know that the manufacturing industry was a thing before AMT. It allows people to get educated. We also offer it as a means to invite other people to come to it, whether it's a local high school that wants to manufacture some parts for their first robotics team, or it's a potential member that wants to is a little unsure as to whether or not they should invest in robots or automation. Come to our test bed. We have a robot. See what it's like. And if you like it, by the way, this one, the one that we have here, I mentioned a U Factory earlier, the current collaborative robot, 6-axis collaborative robot that we have on our test bed now is an Aegis Rebel 6. That's a sub $6,000 collaborative robot. And sure, it's not as strong as your multiple tens of thousands industrial collaborative robot. But the Aegis robot's meant to be broken. Like you're meant to learn on that. It's all of the parts are replaceable and inexpensively replaceable. You're meant to get your head start on that. People might want to, one of our primary products here at AMT is the MT Connect standard. And a lot of people want to utilize MT Connect because MT Connect allows you to pull data from multiple different brands and models of machines, read that data, and utilize that data from those devices to calculate things like expected tool life, expected maintenance intervals, what kind of maintenance needs to be done on the machines, what's the OEE, what's the productivity of our shop look like. And a lot of these potential customers who want to implement our open source communication standard for the manufacturing industry want to be well, how do we even get started on it? Come to the test bed, check it out, see what you can do here, see how we implemented it, talk to us to see how easy it is, what kind of equipment you're using, how it would look like to implement it. And it's funny, I was talking about the Pixar and USD and OpenUSD earlier, and I this week I made the analogy between Pixar is to USD and OpenUSD as AMT is to MT Connect as the standard. And there's a lot of potential for work that you can get done on our test bed, and we do a lot, and we have a lot of technology on it.
It sounds extremely exciting, this test bed, and a lot of new technology that you guys can test out and fiddle around with that potentially the single mold makers or die makers or whatever cannot do. So I congratulate you for doing this. And I know I could be talking with you for hours on the topics of technology and digital twins and what they do and what benefits they do. If I could ask you this, final thoughts, what would you tell an individual or a company that is still on the fence of maybe not going to the IMTS, maybe they have not registered yet? What would you tell to that people as your final thought?
That haven't registered to IMTS and haven't thought about coming to the show?
What are they missing?
They're missing a universe of not opportunity. Well, definitely opportunity, but more so inspiration. You'll see a lot of different people doing different things in different ways, and there's more than one solution to every problem. Now I sound like a salesperson because this isn't a product, this is a solution. It's yeah, no, what problem? But forget the problem. Just go there for the inspiration. Go there to be inspired, to see where we came from as a civilization, not just an industry, and get a solid glimpse as to where we're going, where the future is.
Steve, I could talk with you for hours. I want to thank you from the bottom of my heart, and hopefully we can have you on here at the All Access podcast again here very soon. I'm going to be looking forward to you at seeing you at IMTS.
Dude, it's been a real pleasure. This has been a blast. It's a pleasure to meet you. This has been really fun. I hope I can come back, and I hope there's all this psycho babble isn't too hard to edit.
No. I think it's going to be great. It's going to be a great episode for all of our listeners. And thanks again for being on the All Access podcast. My friends, from my side here, I think you heard a lot about how important it is for digital twins, how important it is to automate and to get onto that horse so that you can prepare for the future. It's not too late. You can still do this. And IMTS is coming up September 9th through the 14th in Chicago at the McCormick Center. And here's a little plug. Look for Tevis. Tevis booth number 133230. I finally said it correctly here. See us there. Let's see what kind of automation and AI that we're building into the software. And it's for you. It's for you to gain advantage over your manufacturing partners. Is to be more successful than you ever have been before. And this is what IMTS is there for, to help you gain those opportunities and make it to the top and be as successful as you can be, and make sure that our automation and our manufacturing stays here in the U.S. Let's see what we can do. Hopefully, we're going to see you all at IMTS. Look for Steve at IMTS, and when you see him, pat him on the shoulder and tell him what a great guy he is. If you see me, hopefully you can do the same thing to me. But we look forward to seeing you. If you have any questions or items that you want to bring up, contact us at marketing@tevisusa.com and talk to our lovely staff there. We look forward to seeing you back at the next podcast that's coming up real soon. With that said, I want to say thank you and see you soon. Bye-bye.
Thank you for joining this episode of All Access. Please leave a comment or review with your feedback or what you'd like to hear in future episodes. To learn more about manufacturing technology solutions and Tevis's capabilities, visit our website at Tevis. That's TEBIS.com.